Okay, then next topic is next one, force as magnitude as well direction. So as we discussed, what is force? Pull or push or a physical quantity which can change the state of object or tends to change the state of an object. I already told you. So physical quantity means which is the quantity which is able to measure, is able to measure. Similarly, force force also measure in terms of magnitude. Force is measured force is measured in terms of or in its magnitude. Here magnitude in the sense in some number, in some number and some unit. Already I told you. So newton 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 is the measuring unit. Newton is the measuring unit of force. Newton is the measuring unit of force, right? That means we are able to measure how much force is acting on the body. Just as we discussed, force act between two objects when there is some interaction between. So, how much force is act if the two objects are interacted with each other? So, we can measure the force, I mean how much force is acting, how much force is acting on the uh, or between interacted objects. So we can measure how much force is acting in terms of Newton. In terms of Newton. So 1 Newton is the force. 1 Newton is the force acting on acting on of an object, acting of an object of 1 kilogram mass, 1 kilogram mass, and at a speed of 1 meter per second. 1 meter per second. Newton means force force acting force acting on uh, force acting on uh, an object, force acting on an object of 1 kilogram mass, 1 kilogram mass, and its speed is 1 meter per second, 1 meter per second. Simply, this is an object. When force is applied, is it move with some speed. That speed we can consider as 1 meter. 1 meter per second is the force which can make force acting, or force can make an object, force can make an object of 1 kilogram mass, 1 kilogram mass to move, 1 kilogram mass to move, to move, to move at the speed of at the speed of 1 meter per second, 1 meter per second. So we can write simply 1 Newton is equal to 1 kilogram into 1 meter by second. 1 kilogram 1 meter by second. So force acting, where if the mass of the body is 1 kg, If force is act on 1 kg of an object, when force is applied, then that 1 kg of object is moved with 1 meter by second speed. 1 meter by second speed. So that is called Newton. It is called Newton. So force has a magnitude. Force has magnitude means we are able to measure in terms of some number. And as well, force has a direction. In which direction it acts? In which direction it acts? Left to right to right to left, either north to south to east to west to like that. So vertically down, vertically up. These all are indicates direction. All are indicates direction. If I drop the piece of chalk, it moves towards down. It moves towards down because of the force, as we know, gravitational force. Or when we kick a ball, when we kick the ball, so then what will happen? It moves in a particular direction. So the ball is moving in particular direction because the force is applied under direction. If the force is applied from right to left, or the force is applied left to right. Here, right to left to right denotes direction. Denotes direction. So, force has both magnitude as well the direction. As well, direction. So, it must have direction, magnitude and direction. So how much for example, here a heavy box is placed on the floor. A heavy box is placed on the floor. If a heavy box is placed on the floor, here two persons are able to, two persons are trying to push it on the floor. So here person A and person B. Person A and person B. So person A applied some X newtons of force. Then person B applied Y newton of force. Person A applied X newton and person B applied Y newton. Y newton of force to push the heavy box. To push heavy box. Then how much force is acting together? How much force acting together here? So total force applied by A and B is equal to force by A plus force by B. Force by A and force by B. So we can write X plus Y. X plus Y. So this is called net force. This is called net force. This is called net force or resultant force. Net force or resultant force means the algebraic sum of all the forces acting on the body or acting on an object. So the algebraic sum of all the forces acting on the body, we can call net force or the resultant force. If two forces applied on the object, two or more forces applied on the object in the same direction, applied on the object. See here, in this direction they are applying force here, left to right. So the resultant force or the net force is x plus y. So both are applying same direction, same direction. Two forces like x Newton and y Newton applying on the heavy box in which direction? From left to right direction, left to right direction. So x Newton, y Newton are magnitude, left to right is the direction, left to right is the direction. So force has both magnitude as well the direction. If two or more forces are acting, we need to calculate total force, acting on the body. The total force we can call the net force or resultant force. Net force and resultant force. The resultant force in this case is x plus y newtons. X plus y newtons. For example, if x is equal to 2 newtons, if y is equal to 3 newtons, then we can write 2 plus 3, that is equal to 5 newton. So F net or resultant force. F net or resultant force is 5 newton. So this is called resultant force. Then okay, here same side forces are acting. For example, the heavy box is on the floor. Person A applying force right to left, then person B applying force left to right. So here let us consider x Newton of force by A, y Newton of force by B. A person A applying force of x Newton from right to left. Person B apply force on a heavy box from left to right. How many forces are acting? Two forces are acting. Two forces are acting in the same direction or opposite direction. Same direction or opposite direction? Opposite direction. So in this case, we have to calculate the net force or the resultant force acting on this heavy box by differentiate, by the difference, not subtract. Subtract is different, difference is different. Both are doing minus, but little change. So if the two forces are applied and object acting opposite direction, then the net force or the resultant force acting on the object is equal to the difference between the two forces. You have to take difference between two objects. That means we can write F net is equal to ఇది ఇలా అనుకుంటాం. పాజిటివ్ ఎక్స్ యాక్సిస్, ఇది పాజిటివ్ ఎక్స్ యాక్సిస్, ఇది వై యాక్సిస్, ఇది నెగటివ్ ఎక్స్, ఇది నెగటివ్ వై. కాబట్టి సో ఫోర్స్ యాక్టింగ్ left to right. So positive x axis, first we can take this y plus is called sum. Okay, algebraic sum. Okay, do not take directly minus. Then other one x. Here x acting on the box right to left, that means minus x axis. So we can write minus. So we can take y minus x. F net is equal to y minus x. So instead of subtraction, we need to take difference. Need to take different. Why? Because if it's x is equal to 10 newtons, if y is equal to only 4 newtons. If x is equal to 10 newtons, if y is equal to 4 newtons. According to this, you can say that 4 minus 10, that is equal to minus 6 Newton. So generally we cannot measure force in terms of minus, but instead of that, we can mention the direction. So in those cases, we have to differentiate from high value to low value. Difference high value from high value to low value. In this case, we can write x minus y. So 10 minus 4, that is equal to 6 Newton. 6 Newton of force. Here also 6 Newton, here also 6 Newton. Right? So differentiate. Subtraction ante we know we have to subtract directly from plus value to minus value, whatever. So difference is different. Difference means differentiate between, we have to subtract in which direction the more force is acting, in which direction the less force is acting. So based on that, we have to subtract. Then, so in this way, we can calculate how much force is acting on this box, Then, let us consider the same example. A heavy box is placed on the floor from right to left, 10 Newton of force, from left to right 10 Newton of force. 10 Newton of force. That means here x Newton of force is acting, here also x Newton of force is acting. X Newton of force. Here x Newton, y Newton. Here x Newton, y Newton. So here both side x Newton, same force acting on the object, but different directions, or opposite directions, or opposite direction. Here two forces are acting in same direction. Two forces are acting in same direction, or two forces are okay. Then here what will happen in this case? Two forces acting acting in opposite direction. So here two forces are acting, here also two forces are acting. Two forces are acting in different manners. So here same direction, here two forces acting opposite direction. Here what will happen? Same force is acting on the object, but opposite direction. Here same direction, opposite direction, different forces. Here two forces are acting, two forces are same magnitude in different direction. In this case, how can we calculate the total force or the resultant force? So F net is equal to, both same కాబట్టి ఎలా తీసుకోవచ్చు, x plus of minus x, 10 minus 10, that is equal to 0 Newton. that is equal to 0 Newton. Here 0, here 5 Newton, here 6 Newton. Here 0, here 5 Newton, here 6 Newton. So in the second case, the object to move from right to left. Here the object to move from left to right, but what about here? The heavy box can move in any direction, either from left to right or right to left? No, it won't move because of total force, the resultant force, total force by these two persons A and B. A and B. A person A applied 10 Newton of force, person B also applied 10 Newton of force. So both are opposite direction. One is left to right, other one is right to left. So total force acting on the heavy box is zero. That's why no change. Here we can find no change. No change. That means the heavy box doesn't move. The heavy box does not move because of say the total force acting on the box is equal to 0. Here 5 Newton, where to where? Left to right, because of same direction forces, two forces acting same direction. So left to right they can move. Here right to left can move because of from right to left more force is acting. So this is about force has magnitude as well direction. We know tug of war. So both teams, team A and team B, both applied same magnitude of force but opposite direction. They are trying to pull, team A trying to pull team B, a same thing, team B trying to pull team A. So both teams applied same force. One team B from left to right, team A from right to left. Total force acting on that in the game tug of war on the rope is equal to 0. So the rope doesn't move. That mark wherever we have to give, wherever we tie the thread, tie the cloth, whatever, it cannot move. But if the team B apply more force, then the team A pulled towards team B. If team A applied more force, then the team B moved towards team A. So in this way, force is applied on the objects. From this, we can conclude that force has magnitude. That means it has some number. We can measure with some number. 2 newtons or 3 newtons or 10 or 5 or 6 or 12 or 20 or whatever. As well, we can mention the direction. Left to right, right to left, up and down, means vertically up, vertically down. So whatever, we can show the direction, we can measure the force in terms of magnitude. So force has both magnitude as well direction. So based on this net force, we have some problems. So additionally, I'll give you some problems how to calculate the resultant force, and resultant force are the net force by solving some problems. After effects of force topic, I will explain.